UK government has set itself the target of building the world's first nuclear fusion power plant here by 2040. Nuclear fusion is the process that takes place in the heart of stars like our Sun, and recreating it here on Earth could create an unlimited, clean energy source. Dr. Fulvio Militello, a fusion scientist with 20 years' experience, is currently the director of tokamak science at the MAST upgrade experiment, which is testing the spherical tokamak design. It doesn't look like a sphere to me. It looks like a cylinder.
It is a cylinder that contains a sphere.
Ah, a sphere of plasma.
Yes, correct.
I see.
Correct.
We haven't yet cracked fusion. We haven't got more energy out than we put in. Why are we experimenting with the shape?
We have fusion every day in our devices, but as you correctly said, we have not yet managed to amplify the amount of energy that we put in the device. A future power plant is going to be fundamentally an energy amplificator. You put a lot of energy in, you get much more energy out. The spherical design allows us to use less space. They give us a more compact device that can use more efficiently the magnetic fields that we're using to confine the plasma, to keep it in place. It is a way of reducing the cost of a future power plant.
While Dr. Militello and his team work on the plasma physics, the engineering challenge of building and running a fusion reactor is also being tackled.
We recognise that you're trying to create a star, and we're thinking about the bottle that you're going to put the star in.
Right.
Yeah?
Yep.
So that bottle is going to be damaged by the star, because the star that we're creating, this very, very hot plasma, is radiating stuff. That stuff is very energetic, so we've got lots of energetic particles that are flying off this plasma. Those particles are going to fly into the bottle, and the bottle is going to get damaged. So let's say if we were in there, we would just get vaporized, literally. I mean, because there's so much energy, which is what you want, but that energy would just destroy biological material. So we have to use robots that are made of metal. We have to use a bottle that is made of metal so that it actually can last.
Matty Kearney is one of a number of mechanical engineers working at RACE. This is kind of the same sort of robot that you'd see in a car factory.
Yeah, they're very similar robots. It's just different software. So, again, it's software development that's going on here.
So even though these machines are very big and grunty, we're actually talking about what you're working on is not the hardware, it's the brainware, the software for these.
Yeah, so a lot of these, they're just off-the-shelf robots. So the research that we're doing is all about the software development.
But you're also developing engineers of the future over there.
Yeah, we have a lot of graduates. Every year we get a big intake of graduates, so we're doing some training. So just a bit of appreciation of how the robots work.
350 people a year are being trained to be the fusion engineers and technicians of the future. So one of those graduate students we saw this morning in 2040 may be the one who switches on STEP.
Yeah, exactly, yeah. That's the plan.
It's a good plan.